Hello, my name is Don Sisk, and I'd like to extend my gratitude for your interest in the courses we offer at PAST Consulting Training Service. Thank you for selecting us as your training provider. You've clicked on this video link because you're either aspiring to become an electrician or are currently working in the field and wish to further your education. I appreciate your presence here and would like to take a few moments to share some pertinent information about the electrical world of construction. I began my electrical apprenticeship in 1979, coinciding with the initial publication of the NFPA 70E standard for electrical safety requirements in the workplace. Today, NFPA 70E is central to electrical safety practices. During the early stages of my career, I had the opportunity to work in the power distribution branch of my employer's company. We handled the conversion of high incoming line voltage to lower voltage, facilitating power distribution for office trailers and temporary circuits that was needed by craftsmen during the construction phase. These experiences were often exhilarating. Regrettably, safety was not prioritized as much as project completion, and that led to severe electrical shocks that were suffered by close friends and co-workers. Over the following 15 years, while industry practices remained largely unchanged, workplace safety saw significant improvements. It was around 1994 that I encountered NCCER, that's the National Center for Construction, Education, and Research. They're an organization that's committed to promoting safety. As a seasoned journeyman electrician, I had honed the skills to work safely, including implementing things such as control of hazardous energy, which is commonly known as lockout tagout. I became an electrical instructor for NCCER, and I felt like this was going to be the best way to keep my coworkers safe. So we're going to be able to share some ideals with you, and I want to get right into it. Electricity is generated at a power station and transmitted through power distribution lines to residential, commercial, and industrial users. At each point on the power distribution route, maintenance personnel must install, connect or disconnect, adjust, and maintain the equipment used to generate, transmit, and consume electricity. At each point along this route, it represents hazards that can injure or kill personnel, whether they are working directly on the equipment or not. Anyone working on or near electrical equipment may encounter shock, arc flash, or arc blast hazards. When a person in contact with ground or grounded objects contacts an energized part, that person receives an electric shock. Electrical shock can also occur when an internal fault causes the cases or enclosures of tools, appliances, or electrical equipment to become energized. The danger from electrical shock depends on the amount of current flowing through the person, which is a function of voltage and body resistance, and it may be calculated using Ohm's law. Using the formula I is equal to E over R, where I is the value of current measured in amps, E is the voltage, and R is the resistance measured in ohms, we can determine that a 120 volt power source touching a person's body hand to hand with 1,000 ohms of resistance would equal 0.120 amps or 120 milliamps. How shock occurs: the current enters the body at one point and leaves at another. Did you know approximately 30,000 non-fatal and 1,000 fatal electrical shock accidents occur each year? However, the majority of hospital admissions due to electrical shock are from arc flash burns, not from shocks. And the resources of this statistic can be found in the NFPA 70 Electrical Safety in the Workplace in informative Annex K. Table 1 below shows the effects of current on the human body. Current is measured in amps or milliamps, and a milliamp is 1/1000th of an amp. Current levels above 150 milliamp can cause the heart to go into a state of fibrillation, abnormal rhythm. This condition is fatal unless the heart rhythm is corrected using special defibrillation equipment, such as an AED. Other effects of electrical shock may include entry or exit wounds from high voltage contact and thermal burns. In addition, the body's reaction to the shock can cause a fall or other accident. Electrical faults may occur when safe work practices are not followed because of equipment failure or both. Two common types of electrical faults are bolted faults and arc faults. A bolted fault occurs when a low resistance connection or short is made between two conductors at different potentials. Circuit protective devices are designed to interrupt a bolted fault before it causes damage to equipment or to conductors. An arc fault occurs when an electrical current jumps or arcs the air gap between two energized sources with different potentials, or between an energized electrical circuit and ground. The current is called arc fault current. Electrical arcs occur in the normal operation of nearly all electrical equipment. Whenever a small arc is not interrupted and it grows into a big arc, it creates an event called an arc flash. The duration of the arc and the amount of arc current flow determine the intensity of the arc. An arc flash generates a very bright light and can reach temperatures up to 35,000 degrees Fahrenheit. Blast pressure from an arc can blow enclosures apart and people away from the source. The hazardous effects of arc flashes must be evaluated to determine the type of personal protective equipment, PPE, that is required when exposed to an arc hazard. Note, PPE that is used to protect against arc flash or blast hazards must be rated for the anticipated energy exposure. There are two main methods of protection against electrical hazards, and they are insulation and grounding. A GFCI is a fast-acting circuit breaker that continually matches the amount of current that is going to an electrical device against the amount of current that is returning from the device. And whenever the two values differ by more than 5 milliamps, a GFCI interrupts the electric power. Now, OSHA requires employers on construction sites to provide either GFCIs, or they have to have a scheduled and recorded assured equipment grounding conductor program. Ideally, work on or near electrical equipment would always be performed with no electrical power applied. This is also known as an electrically safe work condition, but that is not always possible. Distance is the best protection against electrical hazards. The National Fire Protection Association, NFPA 70E, the electrical safety in the workplace, establishes specific limits of approach to exposed energized parts. These are called approach boundaries and are determined by performing a shock hazard analysis. The two types of boundaries are arc flash boundary and the shock protection boundaries. Note that in the arc flash boundary is determined independently and may be at greater or lesser distance than the shock protection boundaries. Only qualified persons are allowed within these boundaries. Unqualified personnel must be trained to stay away from the potentially dangerous electrical equipment and processes. NFPA 70E identifies electrical shock boundaries as the limited approach boundary, the restricted approach boundary, and the prohibited approach boundary. Each boundary has its own hazards and PPE requirements. The warning actually is indicating any worker that is exposed to electrical hazards must be qualified to manage the hazard and using appropriate PPE. If they are not exposed to electrical hazard but they have the potential to be, they still must be informed of the hazards and instructed on how to avoid it. In 2015, NFPA did remove the prohibited approach boundary from the NFPA 70E standard for electrical safety in the workplace. In this brief presentation of the electrical safety module, we explored safe practices when working with electricity, its impact on our daily lives, and associated hazards. For more information with regards to NFPA codes or other safety precautions to take when working around, on, or near electricity, I would encourage you to visit NFPA's website at www.nfpa.org, or you can contact us about signing up to register and attend additional electrical safety training. Thank you again for watching this brief video and learning about what PAST Consulting Service has to offer. Please contact us for more information on upcoming training opportunities, or you may visit our website at www.pastconsultingtraining.net. We look forward to serving as your training provider and educational resource. Together we can ensure the safety in our endeavors. Remember our catchphrase, learning from the past and training for the future. Thank you.